Thank you again and welcome to my YouTube channel. In today's tutorial, I'm going to teach you about the pressure in fluids and specifically I'm going to teach about the fluid pressure formula. So before we talk about the fluid pressure formula, we need to know some definitions like pressure and also what is a fluid. Now, from the definition of pressure, pressure is always the force. A force acting perpendicularly per unit area of a given body. Force acting perpendicularly per unit area. That is the definition of pressure. Now, a fluid, definition of a fluid is either substance which is in gaseous form or the liquid form. So a fluid can either be a gas or a liquid. That is a fluid. So the pressure, we have the definition of it on the board and also the fluid. Now, let me teach you about the fluid pressure formula. The fluid pressure formula. In the fluid pressure formula, we're going to consider a container having a cross-sectional area, that is a cylindrical container with a cross-sectional area A and containing a liquid of density ρ to a height h. Now we write, consider a container containing a container with cross-sectional area the cross-sectional area of this container is capital A, cross-sectional area A, with a liquid of density filled with a liquid the density of this liquid is ρ because it is unknown to the height h. The height of the liquid in the container is small h, as shown below. Now, a container is cylindrical in shape, and the cross-sectional area of this container is capital A, and it contains liquids of density ρ and the height h, as shown below. So I'm going to illustrate that one in the diagram. Now we have a container containing liquids up to this height on the base. So the depth of the liquid is h, and this is the liquid inside the container. Then, additional information is that the container has a cross-section area A, capital A, then the density of the liquid inside the container, so density of this liquid, is ρ. That is ρ, the symbol, the Greek symbol for representing the density of a liquid. Now, from the diagram above, we can derive the fluid pressure formula. Now, the fluid pressure formula is derived as follows. The pressure P exerted at the bottom of the container. So we write the pressure P exerted at the bottom of the container by the liquid. The pressure exerted at the bottom of the container by the liquid is given by the formula. Now the pressure is the force acting perpendicularly per unit area. So the pressure we denote it by P is equal to the force exerted by the liquid over the cross-section area of the container. So the force exerted by the liquid in the container is known as the weight. This is the same as the weight of the liquid in the container over the cross-sectional area of the container, which is area A. Now, we have been given the density of the liquid, we have the cross-section area of the container, and also the height, the level through which this liquid is in the container. Now, the weight of a substance is always equal to the mass of that given substance you multiply by the gravitational field strength. So write the weight of a substance is equal to the mass of that given substance multiplied by the gravitational field strength. I just cite gravity. Mass multiplied by the gravitational field strength in that given space. Now, we can get the volume of this liquid. The volume of the liquid inside this container is equal to the cross-sectional area of the container multiplied by the depth of the liquid in the container. Now, the volume of liquid is equal to the cross-sectional area of the liquid, which is capital A, times the height of the liquid in the container, which is h. This is equal to AH. Now we have the volume of the liquid in the container is AH. Now, the density of the liquid is equal to rho. Now we can get the mass of the liquid because we have the volume of the given liquid, the density. Now we can get the mass. So the mass of the liquid is equal to the volume of the liquid multiplied by the density of that liquid. So the volume of the liquid is AH. So this is equivalent to AH multiplied by the density, which is rho. This gives you AH rho. This one is the mass of the liquid using the given information from the statement before we are starting our calculation here. Now, we have the mass of the liquid. Now we can get the weight. So this brings us to a point that weight of the liquid is equivalent to the mass. The mass of the liquid is AH rho. AH rho multiplied by the gravitational field strength, which is G. So the weight is AH rho G. Now, so the weight of this liquid given using the information given from the statement is AH rho G. Now to find the pressure exerted by this liquid at the base of the container, we go back to the formula. The pressure is equivalent to the weight. The weight of the liquid, which is AH rho G, over the cross-sectional area of the container, which is A. So we find A and F. So the fluid pressure formula P is equal to the product of height of the fluid, that is the depth of the fluid, multiplied by the density of the fluid and multiplied by the gravitational field strength, where P represents pressure. P stands for the pressure in this case. So where P is equal to the pressure, then H is equivalent to the depth of the liquid. Depth of liquid that now can be a fluid. Let us just talk about the gas or the liquid. So depth of the fluid. Then rho represent the density of fluid. Then G, this one represents the gravitational field strength of that place. Now that's how we derive the fluid pressure formula. Because we don't have the given numbers. We just use the symbols for volume, the cross-sectional area, the height, the gravity. We just use the symbol and the density. Now, let me now teach you about the factors affecting pressure in fluids. Before we have a question to discuss on this given subtopic, factors affecting pressure in fluids. Factors affecting pressure in fluids. Now, we have three factors which affect the pressure in fluids just from the fluid pressure formula. The fluid pressure formula, pressure P is equal to the height, that is the depth of the fluid, multiplied by the density of the fluid, multiplied by the gravitational field strength. So the first factor which affects the pressure in fluids, number one, is the depth of the fluid. So when you have a large depth, the pressure is also going to be large. The pressure in liquid or any given fluid is always increasing with the depth of that given fluid inside the given container. Then we have the density. The first factor is the depth of the fluid. The second factor is the density. Now, the higher the density, when the density of the fluid is bigger, the pressure is also going to be bigger. When you have the density of the fluid being small, the pressure of the fluid exerted by the fluid is also small. Then the last factor affecting the pressure in fluid is the gravitational field strength of that given area. Now, when you have a bigger gravitational field strength, results to bigger pressure exerted by the fluid in that given container. Now, let us look at the examples of questions involving the pressure in fluids. Examples, we just have to do with one example. And the question reads, a diver working underwater is 15 meters. Let me just write it on the board. A diver working under water is 15 meters below the surface of the sea. Full stop. Calculate the pressure due to water experienced. The pressure due to water experienced by diver. Full stop in the brackets. You have been given the following constants. Take G. Take G is equal to 10 newtons per kilogram, comma, and density of seawater to be equal to equal to 1.03 grams per cubic centimeter. That is the density of seawater, equal to 1.03 grams per cubic centimeters. So that is the question that I want to solve now. Now this diver is below the sea level, the surface of the sea now. It means that when the diver is below the surface of the sea, water itself is exerting pressure on the diver now. Because this guy is inside the water, that is the fluid. So the fluid pressure formula, pressure P, is equal to the height of the fluid multiplied with the density of the fluid multiplied with the gravitational field strength. So this is the same as the height. The height of the fluid, in this case, the diver is 15 meters below the surface of the sea. So the height is 15 meters. The density of the fluid, that is the density of seawater, is 1.03 grams per cubic centimeter. 1.03 grams per cubic centimeter. Now this density, we are going to convert it to the SI unit of density, which is always in kilogram per cubic meter. So the relationship between the gram per cubic centimeter and kilogram per cubic meter is always 1 gram per cubic centimeter is equivalent to 1000 kilogram per cubic meter. So this implies that when you have 1.03 grams per cubic centimeter, this gives you 1030 kilogram per cubic meter. You just cross multiply to find that the value here is 1030 kilogram per cubic meter. Now this is the density of the seawater in SI unit. Then the gravitational field strength in G is equivalent to 10 newtons per kilogram. Now we substitute the given constant in the fluid pressure formula. So the pressure P is equal to the H rho G. The height is 15 meters multiplied with the density of seawater, 1030 kilograms per cubic meter, times the gravitational field strength on the surface has been given to be 10 newtons per kilogram. So kilogram and kilogram cancel, so we have 15 times 1030 multiplied by 10. So the answer is 154,500. So the pressure exerted to the diver pressure is equal to 154,500 newtons per meter square. So that is the pressure exerted. Thank you for your time, and subscribe for more updates and the education video. Thank you.